Hello children, we are given a pair of linear equations 3x minus 5y is equal to minus 6 and minus 6x plus 10y equal to 12. Let us solve this pair graphically and find the solution. So in order to plot the graph, we need two coordinates for each equation. So we'll go ahead finding the coordinates. This form of y is equal to ax plus b, that is if you make the subject as y, this form facilitates us to find coordinates easily. We can assign random values to x and find the corresponding values of y. So let us rewrite both these equations in that form. So now if you take the first equation, let's call this the first equation. In terms of y, if you write it, minus 5y equal to, let us add a negative 3x to both sides. So you get negative 3x minus 6. Now since all are negative, I can just multiply by minus 1 and write it as 5y is equal to 3x plus 6. This avoids confusion further. You can even avoid this step. Now divide throughout by 5 and isolate y. So y is equal to 3 by 5x plus 6 by 5. This is what we required. Y is equal to ax plus b. Now let's do the other side also. The second equation also. This is your second equation, right? What is it? Negative 6x plus 10y. So you have 10y is equal to, you add a positive 6x to both sides. What happens? This gets cancelled and here you get 6x plus 12. So dividing throughout by 10, you get 6 by 10x plus 12 by 10. Now since both the numerator and denominator is has 2 as common, or they are multiples of 2, you can divide by 2. And here also, even the constant term, you can divide by 2 as they are multiples of 2. So y is equal to, you get 3 by 5x plus 12 by 10 is 6 by 5. So now we have two equations. Now our job is to find coordinates. But look at the equations. They are one and the same. 3 by 5x plus 6 by 5. Here also y is equal to 3 by 5x plus 6 by 5. Why did this happen? Maybe this happened because if you observe these two equations, they are also one and the same, in the sense that if you multiply 3 by minus 2, minus 5 by minus 2 and minus 6 by minus 2, that is each term is multiplied by minus 2, you get the second equation. Just see, I can equate the second equation, minus 6x plus 10y is equal to 12, to be equal to, or let me change this to the other side, isn't it? So equal to 12 is what? It's minus 12 equal to 0, right? Minus 12 is equal to 0. Can be expressed as minus 2 multiplied by this whole thing, the first equation. 3x minus 5y plus 6 is equal to 0. Just check. 2 into 3, minus 2 into 3 minus 6. Minus 2 into minus 5 will give you plus 10. Minus 2 into plus positive 6 is going to give you minus 2. So it's one and the same, just that one is a multiple of another, right? They represent, they would naturally, let's see, we can plot only one line, of course, because both are the same. When you reduce it to the y is equal to x plus b form, both are the same. So let's graphically plot one line. Of course, the same line is going to represent both our equations. So this is your x-axis to denote all your x values, and let me also let the y-axis. Sorry. I'll have to choose it again. Yeah. So y-axis, which denotes all our y values. Oh, we are yet to find the coordinates. We've just found the equation. So let us find the coordinates before we plot. Let us graph key. So let's assume values of x and y. I'll do the coordinates down here. We'll rewrite the equation. y is equal to 3 by 5x plus 6 by 5. This is your equation for which we have to plot 3 by 5x plus 6 by 5. So we'll find the x and y values. So let this be the x value, let this be the y value. Let us take x as 5 first. If x is 5, what happens to this equation? 3 by 5 into 5 plus 6 by 5, which becomes 3 by 5 multiplied by 5 plus 6 by 5, which becomes 3 plus 6 by 5, which is equal to 5 3 is 15. So 15 plus 6 by 5. If you take a 5 as the least common denominator, you get 15 plus 6 by 5, which is 21 by 5. So it's better to express it as a mixed term, because of a mixed fraction, so that you can conveniently plot it in a graph. So 5 ones 5, 5 fours are 20. So 4 and 1 by 5, right? Now, so the corresponding value for y would be, if you take x as 5, y would be 4 and 1 by 5, a little more than 4. Now let us try negative 5. What happens if you take negative 5? So this becomes 3 by 5 into minus 5. So this becomes minus 3, isn't it? It becomes minus 3. So this becomes minus 15. So the answer changes from here. What is minus 15 plus 6? Minus 15 plus 6 is minus 9. Minus 9 by 5. So 5 ones 5. So negative sign remains. 1 into 4 by 5 would give you minus 9 by 5. So this coordinate would be minus 1, 4 by 5. It's towards negative 2 actually. So let us plot the points now. Marking, you have in the x-axis you need till 5, right? 3, 4, this is 5, and this side also minus 1, minus 2, minus 3, minus 4, this is your minus 5. And what about the y-axis? On the positive side, you have a value which is a little above 4, so till 5, and negative side, this is more than enough for you. So this is minus 1, this is minus 2. So what is our first coordinate? The first coordinate is 5 comma, let me write it here, 5 comma 4 and 1 by 5, and the second one is minus 5 comma negative 1 and 4 by 5. So 5 and 4 and 1 by 5 is a little above 4. So this point, right? And negative 5 in the x-axis is here. So it's a little, it's not a little, it's a little in the negative side, of course. Negative side, it would fall here. This would be your 1 and 4 by 5 in the negative side, right? So now, yeah, 1 and 4 by 5. Now let us join these two points of, once again, yeah. The points are too far away. Let me try. So, yes, this is the line. This is the line which represents both your equations, both the equations given. So, if I want to draw another line over it, I mean, if I want to represent both the lines, let me draw in freehand a red line over this. These red line represents the second equation. Any one of them would represent the first, and any one of them would represent the second, because both are the same. They are coinciding. See, both the lines are coinciding. They are one over the other, overlapping. So I can call them coincident or overlapping lines. So what about the solution? Every point in these lines is a solution to these pair of linear equations. Every point you take in this line, in fact, the lines are made up of all the solutions. So you have infinite number of solutions. You have infinite number of solutions for this dependent pair of linear equations. Infinite number of solutions if you have a dependent pair of linear equations, right? I hope you understood. Thank you.